you is just to kind of show you the equations and how you can tell that. And then I'm just going to do one of each type just to review, really. Okay? So I'm going to start with, I'm going to do these out of order. I'm going to do the parabola first. Here's why. I think parabola is the easiest figure to pick up from the equation. Now look at this equation. You have a lot of terms, lots. That capital A, capital B, capital C, all of those letters just represent numbers. So that's just their generic number holder. Now, for me, easiest to figure out a parabola, there is only one squared term in the equation. So that means either A is 0 or the C, the coefficient in front of y squared, is 0. Or really how I just kind of my short, sweet memory on it, you only have one squared term. It all hinges off the squared terms, my friends. So just to give you an easy example, you only have the one squared term in y. X is not squared. Easy to pick up. All right, let's do circle. Now, circle, ellipse, hyperbola, they all have two squared terms in them, the x squared and y squared. So what we're going to look at is the coefficients on them and the positives and negatives, the signs. So it's a circle when A and C are the same thing. And most of the time, to be honest, on a circle, it's 1. So really, I'm looking at the 1y squared, the 1x squared. That makes it a circle. So easy enough to pick out. Now, ellipse, if you think about the pictures, an ellipse and a circle are kind of similar. Obviously, your ellipse on the board here is more of an oval shape, but the equations are similar. You still have two squared terms. They're still both positive, but you have different values in front of them. So you might have 9x squared and 4y squared. You have different coefficients on them. So for ellipse, I'm going to put when A is positive and C is positive, because that's going to switch when I go to hyperbola. So I'm really just using that circle equation. I'm just going to click it back a slide. I'm really just going to use this circle equation, but I'm going to throw a 9 on here and a 4 on this one, just to mix it up. Plus 6x. So again, I'm really looking at that 4 and the 9. And of course, our last figure we did, obviously the equations are similar. They both have squared terms in them. The difference on hyperbola, you have a subtraction, you have a negative. So we have to have different signs. So really, I'm going to copy down that green equation above. I'm going to throw a negative on the 4y squared. So up till now, we've always told you what the figure is. Now there's going to be a handful of problems. You'll see them on the review. You'll see them on the test, where you have to figure out what type of figure it is from the given equation. So that's the next example. So if you look at the next example, there's one of each. Are you ready? Okay, start with the easy. Which one of those is the parabola? C, because it only has one squared term. Always start with the easy stuff, right? All right, next up. Which equation is the circle? I hear A, B, D. I've heard them all said. It's B. Positive 1, positive 1. Circle has to have the same coefficients. Okay? Which equation, and you're down to 2 here, you got a 50-50. Which equation is the ellipse? D. You need the plus.
I didn't pay attention. I still do that.
And of course, A is our hyperbola because of the subtraction. All right, last thing we're going to do. So, and this is really just to help review for our upcoming test on Friday. So now I just have one of each figure, and we're going to actually sketch the graph and put them in the form. Notice it doesn't ask you for all the nitpicky details. We don't have to get carried away, but we do need to get the graph drawn. First question, what is this? One squared term makes it a parabola. Now, we need to get it into standard form for parabolas. And don't forget in your math, or not your math menu, in your apps and your Conics menu on your graphing calculator, the equations are in there. The squared terms for parabolas have to stay on the left. So I'm going to keep 4y over here. I'm going to leave a blank to complete the square. I'm going to subtract 12x to the other side and the 28 over. All right, complete your square on the 4y. What's half of 4? Squared 4. Okay, now we can factor our left-hand side. Multiply to 4, add to 4, easy enough. And I tried to give you nice numbers today, give you a little break. And I'm going to add negative 28 and 4. You are almost in standard form. You have one last mission to do on this equation. What is it? Pull out the 12 on the right side. You need parentheses on both sides. I'm going to do negative 12, yeah. Okay, now we need to get it sketched. I'm going to try not to get too carried away here. One thing we probably should talk about is which direction does it open? Up, down, left, or right? Y squareds are the horizontal, kind of opposite what you would think. The negative makes it open left. We should probably jot down the vertex. What's our vertex? Watch the order, watch the signs. Although you really can't screw this one up, I guess. I hope not, right? Now, probably the easiest way to draw these, of course, is with the lattice rectum, the length of the lattice rectum. Well, I'm going to need the foci for that, so I'm going to need the 4p value. A little mental math. So remember, the focus point is inside the parabola, so you count the same direction it opens. So it opens left, I'm going to go 3 to the left. Now, I don't have to write down the ordered pair. We're not getting crazy. Last thing I'm going to do to get the parabola drawn is use the length of the lattice rectum, which is 12. So from my focus point, I need a width of 12. So up 6, down 6. 2, 3, 4, 5, 6. Got it. Okay, for the love of math, you know I can't help myself. If you had to graph the directrix, you would go 3 units which direction? Right, right. If I asked you, here's an easy question, for the y-intercepts. Y-intercept. None. Doesn't hit the y-axis, right? That was easy. What about x-intercept? You would have to put 0 in for y. I mean, don't trust my drawing, clearly, right? And find them that way. Okay. Any questions on that? So we just had to sketch it today. All right. Take a look. Tell me first, what sort of shape is it? Circle. 1x squared, 1y squared. Now, circles, I love a circle. Those usually aren't too bad. Let's get the order. I don't like that this is scrambled. So I'm going to put the x's together. We're ready to complete the square. I'm going to do that in a minute. I'm going to leave the room, the y squareds together. Again, leave some room so you have room to add that number. And then I'm going to add 23 over. Got it. All right, let's complete the square on 4. I feel like we do 4 a lot. Half of 4, 2, 2 squared 4. Nice thing, no distributor there. I can just go to plus 4. And I'm going to complete the square on the 6y. Half of 6, 3. 3 squared, 9. Okay, let's factor. So I'm going to do the x's first. Multiply to 4, add to negative 4. Negative 2, negative 2. I'm going to do the y's. Multiply to 9, add to negative 6. You might need your calculator. I don't know. I hope not. What's the right-hand side add up to? 36, which I was nice to you today. I say that because what's your radius? 6. 36 is a perfect square. I made it nice on you. So really, we probably should just jot down the center and radius. We already said 6. What's your center? 2, 3. Good. So nice and easy to draw. We're going to plot 2, 3. And then I'm going to go up 6, down 6, right 6, left 6. I kind of regret this big radius. All right, let's try to draw a circle. No promises. Could be better, could be worse. 2 to go, my friends, 2 to go. Any questions on circles? Okay, next up. What is it? Hyperbola, because of the subtraction between x squared and y squared. Okay, so again, I'm going to first reorder the terms. So x squared, 4x. And then I'm going to do my minus y squared and my 6y. And let's just add 9 over. Now again, kind of nice to you. You're ready to complete the square on x's. That's not going to be a big deal. And we've done 4 for like a million times, it feels like. Half of 4, 2 squared, 4. No distributor on that, so I'm going to go ahead and just add 4 over here. Not quite as easy on y, but pretty easy on y. Before you complete the square, what do you have to factor off the y's? The negative, yeah. I'm going to put a 1 for dramatic emphasis. You don't have to have the 1. But careful on your sign here. That's going to make this minus 6y. Okay, half of 6 squared. Careful. What value are you putting on the other side to balance? Negative 9. All right, so let's total that up. It's not bad for. So I'm going to factor, of course. Multiply to 4, add to 4, 2 and 2. I'm going to do the y's. Multiply to 9, add to negative 6. Negative 3, negative 3. And of course we equal 4. Quick question for you. You told me hyperbola. Obviously that's correct. Am I in standard form? No. It has to be set equal to 1. So I'm going to divide everything by 4. Now, I'm kind of running out of room to rewrite that, so power of the smart board, I'm just, instead of 4 over 4, I'm going to swap that out to the 1. And let's mark it. Okay, easy question. What's the center? Negative 2, 3. Good on the order, good on the signs. Let's graph it. Negative 2, 3. Again, I made easy, nice denominators for you. Square root of 4 is 2. So 2 right, 2 left, 2 up, 2 down. Next thing you have to mark out for a hyperbola is what? The box, the central box. The purpose of the central box is so then you can mark your asymptotes. I knew what you meant, Daniel. And now we're going to determine, is this a horizontal or vertical hyperbola? Horizontal because x comes first. So I'm taking my right endpoint close to the asymptotes. Same thing. Got it. That's all it needs us to do today, sketch it. We don't have to get crazy and answer all the stuff. So you probably have figured out or can guess, what's our last figure? Ellipse. Okay. But let's talk, obviously, why? Because you have 2 positive squared terms. All right, let's complete the square, get it in order. I'm going to go ahead and subtract 4 over. Now, the x's are nice. I don't have to factor anything out. I'm ready to go. 4 again, just to make our lives easy. Half of 4, 2, 2 squared 4. I just try to keep the number small and nice today. Not make it too traumatic on you. Okay, y though, I got to do a little work. I'm going to factor 4 out. 4 times 4 is 16. And again, just trying to make it easy. Half of 4, 2, 2 squared 4. Careful though, you're really putting what number on the other side? 16, 4 times 4. So when I total up these 3 values on the right, we get 16. We don't have 0, so we're good to go here. All right, let's do the factoring. Multiply to 4, add to negative 4. Negative 2, negative 2. And multiply to 4. 4. Again, trying to keep the numbers easy for you. And the last thing you have to do for your ellipse, let's fill that in, to get it into standard form is I'm going to set it equal to 1. And don't forget, your equations are in your calculator. If you're like, ooh, do I set this to 1 or not? I'll put it and see. Okay, I'm going to fill it in here. I gave you a nice, perfect square denominators. You are welcome. So generous. All right, let's mark it. What's your center? 2, 2, nice and easy. 16's under x. What's the square root of 16? 4. So 4 right, 4 left. 4 is under y. Square root of 4. 2. So 2 up, 2 down. Let's try to draw the oval. Not bad. Now, if I asked you, just for the thrill of review in our test on Friday, what is the length of the major axis? 8. Minor axis? 4. With the vertices, are those the left and right points or the top and bottom? Left and right because they're on the major. And we're not going to get crazy and do it, but just humor me. What's the calculation you have to make if I needed eccentricity?
C over A.
C over A, C over A, which I didn't even do C or anything, just review it. Okay, last thing we're going to do is pull out that last page. So we have the last 3 problems to do on those final exam review ones. I really want to do 8. You can tell from 8 that that's a big one. I'm going to hold off still on 8 because I want to wait till like most everybody's here. I know we're missing people because of testing, but let's do the last ones, 9 and 10. We just did these. I have no clue why these are on like the commonly missed list of stuff. I don't know why we're getting this wrong. 1 squared term, what sort of shape is it? Parabola. That was pretty tough. Pretty tough. Thank God it'll be multiple choice. You won't have to spell it out in the final. Okay? What's this, guys? Ellipse. You have the 2 squared terms with different coefficients, both positive. So you should have everything